Hey everybody, the protein I chose to do my project on is the TAU protein, also known as the tau protein. Before we get started, I just want to give everybody a quick heads up that between the beginning and the end of the slideshow, there's going to be a little bit discrepancy about the size of the protein and its primary structure, but we'll get to that when that time comes in the slides. So, why I chose the tau protein? I served in the military for 12 years, deployed multiple times to combat zones. Here you see a picture of me and a bunch of the guys I was deployed to Afghanistan with just a couple mornings before we left for Afghanistan in 2012. Um, and the reason this protein was so important to me is because the tau protein has a lot to do with chronic traumatic encephalopathy, which studies have shown that 14% of service members who have experienced a blast have evidence of CTE. And blast was the most common injury experience there. So it's kind of near to me because I'm probably at a high risk, and so are some of my friends. So the simple beginnings of the structure of the protein, the primary sequence is 128 amino acids. You can see the sequence here on the screen. Currently, they've only identified one subunit, and this goes to the point, which we'll also touch on later, about it being a larger protein. We know it's much larger. We just haven't identified the sequence of those other pieces, those other subunits yet. Um, it can be found in the data bank with the coordinates 2A, YA. As you can see, the secondary structure here has multiple alpha helixes and one beta sheet consisting of three beta strands. The structure includes, or the primary structure, or excuse me, the secondary structure includes hydrogen bonding. If you look closely, the tertiary structure consists of bonding from alpha helix R groups that are close together. If you look at the third image to the right, you can see where some of them are close together, and that structure would have bonding from hydrogen. The tertiary structure, sorry, we were talking about the tertiary structure. My apologies. It'd have hydrogen bonding, ionic bonding, and van der Waals. This right now doesn't have a quaternary structure because it is one subunit, but just like the tertiary structure, it includes hydrogen bonding, ionic bonding, and van der Waals. I put a couple pictures up here. The first one you can see is from the data bank. The second one allows you to see the beta sheets a little better, and then the third one you can see where the alpha helixes may may come together for a tertiary structure because they're so close. So the functions of the tau protein, it has one major function, and that major function is to stabilize microtubules, which are found in the neurons in the brain. As you can see, the tau aggregation is a characteristic of several neurodegenerative diseases known as tauopathies. These include dementia, Alzheimer's, like I said before, chronic traumatic encephalopathy, also known as CTE. And we'll talk about a little more about how that happens. So when you take the structure and the functions together, this is where I was saying that there may be some discrepancy in the size. As you can see, it states that the microtubule binding happens with the protein from around the area of 243 to 367, even though I said there was only 128 amino acids. That's the first subunit, the one that we are able to know its sequence. We also know this protein is much larger, somewhere around the 440 ranges, as you can see from the image. We just haven't been able to sequence that yet. So we can't identify exactly what attaches. But as you can see, it attaches to the microtubule, or it bonds to the microtubule to keep it nice and stabilized. And that's the entire point of this of this protein. Um, so what happens when it causes problems is it does misfold, and that's the process that takes place when someone has CTE. It misfolds, and for some reason or another, it's unable to catch the aggregates and make it fold right. But the difference with Alzheimer's is that instead of misfolding, it actually fails to fold and then causes degeneration in the myelin. So demyelination, and it breaks down the myelin, and it ends up killing the neuron. And ultimately, so in CTE, so does the misfold that ends up killing the neuron as well. So that's how it all comes together, and that's how it functions and how it works. Here are some of my references if you guys want to look into them. Yeah, that's all I got. I hope you guys have a great day.